This is Rob Chisholm, and this video is really for RTV viewers, but probably go public at some point. The thing I want to talk to you all about today is more to do with site assessment. Now, I'm just going to sort of show you how my mind works when I go to predict the weather ahead. If we take, let's just make it, there we are. If we take the synoptic chart, which is here, the high pressure, which is basically going to be here, it's going to be a high, and this will be a low pressure. Now you can work out, obviously, I hope it depends on your level and knowledge, but in the northern hemisphere, first of all, high pressure is going clockwise, low pressure is going anti-clockwise. So just for argument's sake, let's say this is Thursday. Let's just say this was Thursday. So you're flying at the weekend. You could obviously understand the low pressure is going anti-clockwise and the high pressure is going clockwise. Okay, in the northern hemisphere. The airflow down here, imagine two wheels. This is spinning around and around. And this low pressure is obviously spinning around the other way. Anything in between will get pulled down there quite sharply. So as this low pressure and high pressure both track and head off to the northeast, that's general flow of where the weather will move. This will allow this high pressure to come in. So if you think ahead, what would it be like on Saturday and Sunday, your days off? You can easily sort of do your own prediction. And it might be the high pressure just simply moves over like that. Now, let's put it. It's moved up a little bit about there. Yeah, about there. That'd do, wouldn't it? So if we said it was about there, you could say what is the wind direction you would predict, and you could say, well, if we had, where is it, obviously, but I'm going to say Brighton down here. So, well, not quite there, really, is it? It's more about there. I would start to say, okay, what's the wind direction? Look at the isobars. What's the pressure? Very important. So I'm going to give that 1008. In the centre, obviously, it's going to be different. So what's it going to be in the centre? Well, we'll come to that in a moment, but we'll just give the centre of the low 998. Now this airflow, when it's coming, it might not actually, although it's coming from the north, it may not originate from the north. I'll just explain what I mean by that. The airflow may be coming up from here, spinning around. It's not coming from the north as such, although it's coming down some pretty old cold areas. Now the pressure, I'll just go back to that. If it was a higher pressure, let's say 1032, that makes a big difference as well. All of this information helps me predict what I think is going to happen on the day. So I'm just going to just talk you through some of this. These are millibars, by the way. The higher the pressure, the more sinking air you'll get. Oops. You'll be flying along, especially with ridge soaring, and you would maybe fly along laminar airflow and hit some sink and go down more abruptly in a higher pressure. If it was 1008, you won't sink so fast. Now, I could go into a lot of detail, but I won't. You just have to either believe me or not, or go and find out for yourself. But the higher the pressure, the quicker you're going to sink. So if you're into ridge soaring up and down the front of the ridge, you're going to find you sink. But the areas I'd be looking for is this wind, northerly wind, so it's quite a cold Arctic airflow. The sun's going to be at 1008 millibars, so the pressure's a bit low. It's not low like a low pressure, is it? But what I'd be thinking about is some areas like this. So I'm just going to hide that out of the way. Leave England there for the moment, UK. So you've got the sun. And we all know where the sun starts in the UK. Very rarely, and it doesn't happen on weekends. That's a Rob joke, by the way. Anyway, look, it's in the east. Oh, it's a bit big, isn't it? The sun's going to be up here. and then the sun obviously will end up in the west, like so. Now, go away emails. So what happens is the sun will be in the east, end up in the west. So what's the importance of that? Going around, makes a big happy smiley face, doesn't it? Well, the importance of that is when you're on a ridge, I'm just going to put that in. If we had, this would be Devil's Dyke. There's the north face of Devil's Dyke. That's the northwest of Devil's Dyke. And this is north facing. Just so we're all clear on that, that means the wind is coming from the north and it's going to hit this ridge here. Or if it was northwest, it will be going that way. So get to grips with that, and then what we'll have is, where will the sun be? Probably we would be better off actually just do this quickly. We went, and we're saying that's northwest. Go around a bit. That's sort of about north, isn't it? There. So east is about there. Well, that's not quite right. That looks like a Z. Anyway, east, that'll be about west sort of thing. Does that look right? North, south? Yeah, roughly speaking. If I put a compass up and we had a bit more time, it'd be brilliant. But we don't. So, the sun basically is coming up in the east, so get our sun again. Sort of, bad here. But Devil's Dyke's quite high up, and it's going to go around to about here. It's worthwhile noting in this time of year, February, March or something, if you're flying along here, you can't see very well because the sun, when it gets low, will put all of this is in shadow. You can't visually see very well, so it can make it very difficult if a pilot was flying the other way, and the pilot's flying this way, and they've got the ridge on their right. You as a pilot going that way, you might not see them. They'll shout at you just before you fly into them. So don't fly in meteorological conditions which are unsuitable, obviously. If you can't see because there's blazing sun, you put sunglasses on. As soon as you get down here in the shadow, you're not going to see anything because it's too dark. You will have an accident at some point. So I always say when the sun gets to about here, that's it. That's my day over. I don't continue to do any more flying, even though people are flying, because I've seen it too many times over the years. People have mid-airs deploys reserves, hang from the reserve, hopefully don't go to hospital and then blame the other pilot. It's a bit like two cars crashing. You're both at fault. So don't fly in VMC if it's unsuitable up and down a ridge. Ridge soaring's dangerous. Being out front in thermals is better. But I'll just going off on one there, so I better come back to the sun. What you will have is the shape of the hill's not like that, obviously, so I'll draw it better in a moment. But you're going to have this aerial marking in blue in shadow. So shadow in the morning. What time will those rays of sunlight actually penetrate this area? Because they'll probably just reach down there, wouldn't they? Depending on the time of year. January, yeah. Because there are some little houses actually, interestingly enough. There are about sort of one there, and one here, there's another one there. Basically all winter they're in shadow. So that's cold air. Now, what am I going on about here? Well, if it's a clear sky and a high pressure at night, remember we've got that high pressure somewhere. Where is it? There we are. There's that high pressure. Then what you're going to have, that cold airflow. All of this is in shadow in the daytime, but at night time, all the heat can get out of the ground if there is any. And this area here, it's pushing it a bit, but I'll go 10 degrees less than up here. There could be that much difference because this is all in sun. This whole area here is in sun. This whole area here during the day. But this area here will thaw out. When that happens, you're going to have a temperature difference. So we're going to look at that a little bit more in detail, just to give you some hints and little tips Here's your northerly ridge. It sort of does all that. Goes around like that, goes around there, goes like that, goes in there, modeller's bowl there. Now, if you think about it, and we put the sun back, I'll just pop this up. There's your sun. It could be there. Now remember, different times of the year the sun's going to change, a bit like spring tides and so on. So what happens is you have to work out where the sun is, what height it's going to be. But at some point the sun, the rays are going to definitely melt the blue area which is in frost. When that happens, you have convection, so you'll have more thermal activity. So going up and down the ridge, you'd be going like this, wouldn't you? Way up in the air, whoa, down in the ridge, bang, bang. It doesn't work. It's not laminar airflow, so don't go ridge sawing then. So all of this area is going to eventually melt because it's colder, gives you convection. You will get thermals. A lot of people think, great, I'll better fly around here. Well, just going to draw that in for you. There's your ridge. Your thermal, bang, punches you. It's not a very smooth ride, so your airflow's travelling up there. You get your thermal here melting, which is about here, convection. It's going to hit you. It's going to hit you like a boxer, smack in the side of the face. You're not going to like it. Your glider's going to suffer some problems. You're going to be up in rising air and then out of it, hitting the brakes, trying to slow your glider down in sinking air. It's not going to work. Ridge saw and laminar airflow is good. So all of this area here is obviously going to convect. You can use the thermals out there, and once you've got a bit of height, come back to the ridge and top up and then climb out. But the thing to do is to remember this here is giving you a better temperature difference. This area here, totally different from the rest of this area, because this is all melted, the ground's all a bit moist now, but this could still be frozen. And it's this little area here. If we were to take just that section there and we draw it like where's it gone? There we are. If we draw it like that, and then we were to put the sun in, the sun, for argument's sake, is we'll just position it here. You'll be able to see straight away. Hopefully, you can see the rays of light, sunlight. They would hit that area there. But this area here, they're going to be hard pushed to get there when the sun, if it was there, the rays of light are just going to go across it. So this little area here, section, is always in shade. So there's a big, and this area over here is now become probably where the thermal activity can take place. This may melt later when the sun gets higher. So those little deviations or separation, and you notice these little things, they make you a better pilot. Just to turn up, this is a classic, and I'm not taking the mickey out of anyone. I get people do this. They said some news people. They said this, Rob. 5 with an arrow, and I go, yeah, what direction's that? And they go, oh, northwest, and I go, okay. And where's it for? And they say Brighton. I say, brilliant. And what did they say about convection? What? Nothing. So the customer can't understand there's going to be a convection with the frost. So I also ask, is this at the top of Devil's Dyke? Because that's 711 feet above mean sea level, so sea level. So that's 711 feet, Devil's Dyke. Or do they mean at sea level? And obviously people start to think I'm being sarcastic, but it's a very good question to ask. There's no point looking at an app that says 5 miles an hour, because it's not telling me much. It tells me the wind direction, but it doesn't tell me, is it 1, thermic? Is it smooth? Does it tell me the pressure? Does it tell me, what else do I need to know? We've got direction, thermic, smooth, pressure. It doesn't tell me the lay of the land. So when I was explaining, and it's getting all a bit messy on here now, isn't it? Yeah. When I was explaining this little area here, where the sun positions and the rays goes to a certain shape of the hill, which is relationship to along this ridge you fly. Certain areas stick out, certain areas, there's a model of bowl, there's a forest, certain areas will heat up quicker than others and therefore produce more thermic air in that particular area. That's where it's going to be triggered and leave. None of these little things that say, oh, next Tuesday it's going to be 4 miles an hour. And it will be southwest Rob. It's not telling me where the airflow is coming from, so it won't tell me if it's thermic, it won't give me the pressure, and it won't tell me what the conditions are like. And that's what you need to be able to prepare and predict. So on this particular day, then we'll wrap it up. I've told you how the high pressure rotates, where it's moving, it's all tracking with the low pressure northeast. Give us a northerly airflow. It's not coming from a northerly perspective as such, it's just a high pressure rotating around. Isobars are wide apart, will be cold, but also more importantly the sun when it triggers off will cause a lot of convection because of areas that are in shadow then out of shadow. Anyway, you got any questions, do ask, because I'm only skimming the surface on, that's what I call a basic CP level. That's what I would expect from a basic CP person coming to me to give a flight plan. If they then said, on a day like this, I'm going to go ridge soaring up and down the ridge, I'd probably say, no, you're not ready for it because you haven't assessed the conditions. You need, that's all it is. That's all flying's about, is being able to assess the conditions. Anyway, wrap it up there. That's Rob at RTV for Free Flight Brighton. Thank you.